Okay, so today's goal is to use proportions to make conversions and to use similar figures to find missing measures. We talked about this in class today. So the first example is Connie went hiking for 4 hours. For how many minutes did she go hiking? Now, I know that you all can do this simply in your head just by multiplying 4 times 60 because it's 60 minutes in an hour. Now, the reason why we're going about it like this is because I want you to start thinking algebraically, and I want you to think about how to solve that, setting it up as a proportion. So the first thing you have to do is set up your units. You're looking at the 2 units you have, which is hours and minutes. So you want to set it up to where you have your hours to hours, because you want your hours equaling your hours. And then the other one, minutes to minutes. You want your minutes equaling your minutes. Okay, so now the conversion is 1 hour equals how many minutes? Okay, you are just converting those 2 units. So for 1 hour, there is 60 minutes. Then you go back to the word problem. They're asking about 4 hours. So you're going to put your 4 in there. And then you're asking for how many minutes was that? So that's our x. So what you're going to have to do is cross multiply. I always start with my x for cross multiplying, just so when it's solving it's easier just to go across, easier to solve with my variable on the left, my values on the right. So 1 times x is 1x, and then 60 times 4 is 240, and that is minutes. Now, we don't have to divide by anything because the x is already by itself. 1x is just plain old x. Let's look at the next example. It said Mr. Williams is 72 inches tall. Find his height in feet. And of course, you already know the answer is 6. However, we have to learn how to set up our conversions and then solve algebraically. So what we're going to do is the same thing we did in the previous example. We're going to look at our units. Our units are inches and feet. So we put our inches to inches and our feet to feet. It always helps to set up your units first. Then you'll know where the numbers go. So you won't get your numbers mixed up. So first we put in our conversion. How many inches in a foot? There are 12 inches in a foot, just like a ruler. And then we're going to put in our information from the word problem. 72 inches is what's given us. And then we're looking for the height in feet. So there you go. That's our x. So now we are going to cross multiply our butterfly. 12 times x is 12x. 1 times 72 is 72. Now please make sure that your equal signs are lining right up. Okay. Now at this point we have to get our x by itself. And right now it is attached to 12 by way of multiplication. You have to do the opposite of multiplication, which is division, in order to get the x by itself. So we're going to divide by 12 on both sides. And what happens is, remember, the 12s cancel out because 12 divided by 12 is 1. The x gets to come down. And 72 divided by 12 is 6. The main thing you have to remember is setting up your units first. Then put in your conversion. Then put in the information from the word problem. Okay? Let's look at the next one. Okay, this is indirect measurement. Indirect measurement is using similar figures and proportions to find a value that you cannot measure directly. For example, to find out how tall a tree is, you're not exactly going to go and climb a tree or take a tape measure and stick it all the way up to the top of the tree and find that. You're not going to do that. You're going to use indirect measurement, things that you can use closer to the ground to find out what the height is. So we have we have a man here versus a tree. The tree casts a shadow of 8 feet. The 6-foot tall man casts a shadow of 4 feet. So we can use that shadow in comparison and his height to find out how tall the tree is. So we're going to do the same thing that we did in class today. This was that example that we talked about in class today. So just like in our previous examples when we use the units, we're pretty much going to do the same thing here. The only difference is our units are what the indirect measurement is. Shadows and then height. Okay, because we're looking for height anyway. So what you can do is you can say shadow to shadow. And then height to height. And you can set it up like this, or you could put both heights on there, or you can and then do both shadows there, as long as it is in proportion. Okay, this is not the only way you could set it up, but in this case I'm using height to height and shadow to shadow. I'm having my height equal my height, shadow equal my shadow. So I'm going to do the tree just because it's on the left side. So my shadow is 8 feet long. My height, I don't know because that's what I'm looking for. I want to know how tall that tree is, so I'm going to put H in there for height. You could put X, whatever variable you want. Then the man, his shadow casting is 4 feet, and then he is 6 feet tall. So now we're just at H over 8 equals 6 over 4. So we're going to cross multiply. We're going to solve like normal. I'm going to multiply H times 4, which is 4H. And then 8 times 6, which is 48. At this point, we just get the H by itself by dividing by 4, because that is the number beside H. The 4's cancel out, and our H gets to come down. Notice my equal signs are all lining up. And then 48 divided by 4 is 12. So that means your tree is 12 feet tall. Okay, so remember, your units get you started. If you figure out what two things you are comparing and trying to put in proportion, you should be able to put your numbers in after that. So do your units first, then substitute in your numbers. Okay, this one is the same type of problem, however, one is overlapping. So you have the lighthouse, and we're going to try to find the height of that lighthouse. We have the height of this flag, and we have the distance from the lighthouse to this end point here, and the distance from the flagpole to the end point here. I want to know how tall that lighthouse is. So the way you have to set this up is we can do height and height. And then we can use this as a shadow. It's not necessarily a shadow, but I'm going to go ahead and say it's a shadow. So I'm going to use this as my lighthouse side right here. And so my shadow from the lighthouse to the end point is 36 meters. Oh, so we're going to put shadow here. So my shadow is 36 meters. And now my height for the lighthouse, I'm just going to put H there. Okay? Now, notice the flagpole is just from here to here. That shadow of the flagpole is from here to here. So my shadow for that is going to be 20 down here for the flagpole. And my height of the flagpole, 8 meters. It's all meters, but what the difference is whether it's the height or the shadow. So now at this point, all we have to do is cross multiply and divide. So we're going to multiply. H times 20 is 20H, of course. Then we're going to cross multiply 36 times 8, and that's going to give us 288. And right now, all we have to do is divide. We're going to divide by 20 on both sides. The 20s cancel, and then h gets to come down. H is now happy, it's all by itself. And then 288 divided by 20 is 14.4 meters. And that's basically it. You're making sure that your fractions are in proportion. Okay? You're making sure that everything lines up. If you have all of your height over here and all of your shadows here, make sure that it's lined up with this is for the flagpole, this is for the lighthouse. Just make sure that it is all in proportion.